Hello and welcome back. This is our final lesson on working out the area of composite shapes, and in this lesson we're going to do a fairly advanced problem, and I encourage those of you who really want to push themselves to have a go at this, and I encourage you to have a go. Do it as much as you can on your own and then play the video to get some help. Okay, so let's have a look at what the problem is. There's our shape. So we have to work out the area that's shaded. Notice there's a hole punched in the middle. So I'll now give you the dimensions, and here they are. So let's just go through these dimensions. This slant height here is 50 centimeters. 20 centimeters there. The distance from the center to the outside here is 25 centimeters, and from here to the inside, or the edge of this hole, is 10 centimeters, and from here to here is 30 centimeters. So I would really encourage you to see if you could work out this area from here, from this point, without playing the video, and then playing the video once you've actually got an answer to check you're working. So I really encourage you to do that. Okay, welcome back. I hope you went well with it. Let's see how you did go. So the first step, like all the other composite problems, is to identify what the basic shapes are in this problem. Now hopefully you may have recognized that the shapes were, firstly, there's a trapezium. Okay, there's a trapezium in there. And the half a circle. So I just drew the whole circle to indicate it's actually part of a circle, but we can see that's a semicircle in there, and obviously a small circle, which is a hole. Okay, so let's now go ahead and work this area out. So first step, write down the names of the shapes that we're going to be identifying or using. And so shape A was a trapezium. And the area of that, the area of a trapezium, is equal to bracket A plus B multiplied by its perpendicular height divided by 2. The second shape was a semicircle. And the area of a semicircle, once again, is pi r squared divided by 2. And the final shape was this hole in the middle, and that was a full circle. And the area of a full circle we know is pi r squared. Okay, pi r squared. Okay, so let's see what we can do here. Now, let's start with the trapezium. So, area of the trapezium. There's our subheading. Now, let's see what we know. Well, there's the top of our trapezium. That's A. So clearly A equals 20. So we know that A equals 20 centimeters. The base of our trapezium, here's our trapezium here. the base of our trapezium is not so obvious. We know that this section here is 30 centimetres, but what's the rest? Well, let's have a closer look. Let's bring our ruler in, and I encourage you to use geometric drawing implements such as rulers and protractors and mathemats to draw accurate diagrams. Often the key to solving these problems is to actually have an accurate diagram to work with. So I'm going to draw a little dotted line down there like this. Okay, so from here to here is 20. Well, that's from there to there. So we know that from there to there, try that again. We know that that distance from there to there is 20 centimetres. Okay, so we're nearly there. We've got this bit, which is 30, and this section, which is 20. What's this bit here? What's that final length? Well, the way to work that out was using something we learnt at the very, very beginning of the year, and hopefully you'll remember it. We're going to use Pythagoras. So Pythagoras' theorem, remember, allows us to work out the side of any right angled triangle if we know the two other sides. So Pythagoras is going to feature in this problem. And so we're going to use Pythagoras. If that's a right angled triangle, we can use Pythagoras to work this out. But that means we need to know what this height is. We need to know that distance from there to there. Because whenever we're working out a Pythagorean triangle, we need to know at least two of the sides. Well, we know one side, we know that's 50. But we don't really know h either, do we? So how are we going to do that? Well, is there another triangle we can use that shares the same height? Yes, there is, and you guessed it, there's a triangle here. This triangle here also is a Pythagorean triangle, so we can also use Pythagoras to work out its missing side. And guess what? Its height is the same as the height that we want. So let's have a look at using Pythagoras for this triangle. We're going to use this triangle here. So we'll just draw a little sketch of the triangle so that we've got something to work with. So there's our triangle. We're drawing the right angle. There it is there. Now we know the base of our triangle is 30. Let's see if we can work out the hypotenuse. Remember, the longest side of the triangle is called the hypotenuse. It's the side opposite the right angle. Well, we know that from the centre of the big circle, from there to there is 25. So that's the radius. That happens to be the radius of our semicircle. But it's also exactly half of the hypotenuse. And we know it's half of the hypotenuse because the radius also goes from there to there, because that's where the semicircle ends. So we know from here to here is also the radius. So from here to here is the diameter of our semicircle, which is going to be 25 plus another 25, so it's going to be 50. So that distance from there is 50 centimetres. So we need to work out the missing side, which is the height. That's the side we want, the height. And if we know this height, that will give us that height. Okay, so let's go ahead and do it. Now remember, Pythagoras is, there's two versions of Pythagoras. If we're trying to find the longest side, it's going to be a squared plus b squared equals c squared, where c is the longest side. But we're not trying to find the longest side here, we're trying to find one of the other sides. And so the version we use is we're going to use b squared equals c squared minus a squared. In other words, we're going to use the version with a subtraction sign in it. Now b, that's what we're trying to find, so we're going to call that h. So b is the h side, so we'll just say that's b. So I can replace my b with the letter h. So I can say it's h squared equals c squared minus a squared. Well, let's label our triangle. Remember, c is always the hypotenuse. It's always the longest side. So there's our value for c there. So c is going to be 50. So it's going to be 50 squared minus a. Well, that's the only other side left. That's got to be side a. So it's going to be 30 squared. And so h squared will equal 50 squared, which is 2,500, minus 30 squared, which is 900, and that equals 1,600. So h squared equals 1,600. Therefore, h will equal the square root of 1,600, which is 40. So we've now worked out that the height of this triangle is in fact, and the trapezium is in fact 40 centimeters. So we'll just zoom out a bit. Okay. So now we've got everything we need to work out the area of our trapezium. Because now, actually not quite, no, we need to now work out this side here. We need to work out that side. So that's our second Pythagoras calculation. We're going to work out, use this triangle now to work out this missing length. Because we now know that this is 40. So we're going to work out this triangle now. Let's draw a little picture of the triangle. There it is there. And we know that that side there is 50. We know that this side here is 40. And if you do your Pythagoras calculation, you'll see that ends up being 30 centimeters. Okay, now, one thing I've just noticed is that I tried to draw a fairly accurate diagram, but clearly that doesn't look like 30 centimeters. 30 centimeters is more like this. So my apologies, it was a bit of an error in my diagram, but never mind, these things happen. So we now know that that distance there is 30. By the way, the calculation for this is going to be very similar to this calculation. It'll be 50 squared, instead of minus 30 squared, it'll be minus 40 squared. Yeah, so come and see me if you actually, or stop the program, stop the screencast, sorry, and come and see me if you still want help with this particular calculation. Anyway, so we now know that B, which is the base of our trapezium, is 30, plus 30, which is 60, plus 20, which is 80. So B equals 80 centimeters. And we also worked out the height. We worked out the height and we found that it was 40 centimeters. There it is there. So it's our height. So h equals 40. So now we can go ahead and work out the area of our trapezium. So the area will equal a plus b, so it'll be 20 plus 80 times the height, which is 40, divided by 2, and that will equal 100 times 40 divided by 2, which will equal 4,000 divided by 2, which is 2,000. So that will actually equal 2,000 centimeters squared. Right, and we'll draw a little table. Actually, I won't bother to rule this time. Okay, and there's our add side, and there's our subtract side. Remember, the trapezium and the semicircle we're going to add, and we're going to take away the hole here. So we're going to add A and B, and we're going to subtract C. Okay, so we now know that the area of our trapezium is 2,000 centimetres squared. There it is there. Okay, the rest should be pretty easy. So the area of the semicircle will equal pi r squared over 2, which will equal 3.14 times the radius of our semicircle, which was 25. From here to here is the radius of our semicircle, so times 25 squared. Let's zoom in actually. 25 squared, and that will equal equals 1,962.5 divided by 2, which equals 981.25. So there's the area of our semicircle. And finally, we will work out the area of our full circle. And I'll just do that calculation down here. So I'll change colour into green. So the area of our circle, which was the whole, will equal pi r squared, which will equal 3.14 times the radius of our small circle. There's a small circle in here. The radius is 10 centimetres. So it's going to be times 10 squared. So that will equal 3.14 times 100, which equals 314 centimetres squared. So now we've got all the areas we need. The area of the trapezium, the area of the semicircle, and the area of the little circle that's punched out. So once again, the last step, the very last step, is to add these, is to add and subtract. So A and B, so A was, oh actually, just, so we're going to add, let's get rid of those letters, they get in the way a bit. So we're going to add A and B, and C is going to be subtracted. So A is this one. So that's A, the area of our trapezium. So it's going to be 2,000. We're also going to add the area of our semicircle, which was B, and that ended up being 981.25. 981.25, and finally the part that we need to subtract, the hole in the middle, was 314. So the final area, so the area of our final shape, or composite shape, will equal 2,000 plus 981.25, and then subtract 314. So our answer will be 2,981.25 minus 314, and that equals 2,667.25 centimetres squared. And if you got that answer on your own, you are an absolute legend. My thorough congratulations. That was quite a challenging problem, given, of course, that it asked you to go back and use Pythagoras as well. So if you got that on your own and you got this final answer, you are an absolute gun, and my congratulations to you. Please make sure that your working is all written down from the screencast, and if you can now refer to the worksheet to go on with the questions in composite areas. Thank you.